Our Skylines Industry and Homes are living testimony to the extraordinary achievements of the engineering profession. But our reputation as a nation of creators is at risk. Enrollment in engineering schools is down, and studies show the United States faces a shortfall of up to 650,000 engineers by the year 2000, a shortfall that is jeopardizing future technology.
You realize that the U.S. has lost some of its competitiveness in high-tech industries in recent years. And quite frankly, it has not lost it because of any decrease in the inventiveness, innovativeness of American scientists, engineers, industry. It's lost a lot of it because of the fact that it wasn't doing the right kind of technology in manufacturing, for example.
One study has shown first-year engineering students change career goals or drop out due to poor grades, lack of interest, or inadequate high school preparation. College administrators say the numbers signal a time for change.
Somebody has to take the first step. Somebody has to say, we are going to commit our institution to preparing our students better in science and tech. If you make that commitment and then form alliances or associations with other colleges, I believe we can see the end of the demarcation in this educational spectrum from high school to college.
In the upstate New York community of Clifton Park, the administration and faculty of Shenendehowa High School saw the national crisis as a challenge. Shenendehowa's technology department began developing a plan of action.
We thought we had a major goal for the department, and that was to provide an enriched technology program for students pursuing college programs in technical fields. And we involved people from higher education, industry, and business to help us clarify that goal and to work some strategies out that would allow us to implement it. We're trying to provide a world-class educational experience for students.
The 4-year pre-engineering education curriculum approved by the school board is designed to provide technology preparation for students in pursuit of careers in the vast array of engineering and technical fields.
I think we found ourselves evaluating the degree to which this program updated the traditional technology, industrial arts, business-related curriculum that certainly many people were crying for an update for, particularly in a large district like this where the overwhelming majority of the students are college-bound.
Today, Shenendehowa's pre-engineering program exposes students to hands-on engineering fundamentals, utilizing state-of-the-art equipment and backed by a faculty and community-based advisory council that make it work. Our program allows students to experience pre-engineering education as early as the 9th grade. Technical drawing, architectural drawing, students learn the rudiments using the basic tools, pencil and paper, and then move to the computer.
We're supposed to be making a model of our house.
Later, scale models are constructed from the drawing.
It's important for these students to begin at this age because drawing is a language of industry. And before they can really take other courses in technology, they need to understand that language.
A car that travels on a particle beam takes shape on paper and is later made into a scale clay model.
He's going to be here a lot longer than we are, and it's his imagination that's going to develop the future, not ours.
Digital electronics turns math into motion for 10th grade students. This complicated maze of wires is a student project in mathematical logic, the same logic that turns on a toaster or a rocket engine.
When I came in and he started talking about logic circuits and stuff, and I mean, the whole class just sat there, I have no idea what he was talking about, you know.
We start them simple. They tend to get overwhelmed. The hands-on experiences aren't there. Once they prove and understand how those logic functions work, we get to the point where even circuits like this are nothing but larger numbers of simple things.
Each course is a building block. Combined, they create a technology foundation of pre-engineering skills. Under the wide-ranging Principles of Engineering course, students actually construct miniature manufacturing plants, utilizing a unique system of plastic blocks, wheels, gears, computers, and robots.
Ford Motor Company, Chevrolet, they are manufacturing their engine blocks using this same technology, automated manufacturing.
The perception that they are playing with toys quickly vanishes and learning takes over.
We found it to be a very valuable experience because they can simulate real-world problems with this level of equipment without having to spend hundreds of thousands of dollars on the real-world equipment.
High-tech kits replicating the pneumatics and hydraulics used on industrial production lines, construction equipment, airliners, and spacecraft are used to teach both theory and practical applications.
This is used to control the air piloted control valve because it's operated by man. It's half teaching ourselves and half of the teacher teaching. So it's not all notes, take down notes and memorize. You gotta teach yourself the principles and how things work. And I think it helps a lot doing it that way. You learn it better.
The team concept, utilized in today's industrial environment, is emphasized as students are encouraged to lend their individual strengths to the problem-solving process. Principles of engineering also includes both theory and practical application of electric motors. Using miniatures of industrial-size equipment, students design their own drive systems and timing devices. Students in the computer-aided design and computer application course develop their design skills creating anything from houses and boats to futuristic heat-retaining beverage containers and intricate machine parts.
This is a timing gear typical of what might be found in an automobile engine. Students are being exposed to this level of design work about midway through this computer-aided drafting course. This level of technology these students are attaining wasn't available to even college students 20 years ago.
This computer-aided design is for a heatsink, which must be manufactured to an exact tolerance. Before a student project can be produced, samples of metals are stress-tested for strength. Using industrial lathes, students machine materials to exact tolerances to test strength and durability. In the Pro-Final course, Automation and Robotics, students bring together the power of the computer and their new knowledge of material strength and robotics to solve a problem and produce a product. In this laboratory, student teams plan and implement a completely automated manufacturing system model. A microcomputer configured for computer-aided manufacturing controls the machining of the part designed in the program's computer-aided drawing class. Tolerances are checked, and then a robot takes over. While developing the Shenendehowa pre-engineering program, it became apparent our funding base would require outside support to succeed and expand. We looked to Rensselaer Polytechnic Institute in Troy, which had just received a state grant to establish a program in robotics. After careful consideration, the RPI Center for Advanced Technology provided nearly $70,000 in seed money to help establish our program and purchase classroom equipment.
Well, the return for RPI is future students, frankly. The fact is that this, I think, is going to stimulate more kids to be interested in studying science or engineering than would otherwise be the case. And Rensselaer gets about 80% of our students major in either science or engineering. So we're very heavily dependent upon an influx of students who are interested in those subjects.
Next, we sought support from the area business and industrial community and found it anxious to contribute not only equipment for our laboratories, but hours of invaluable mentoring and classroom instruction.
The dollar is a big problem. Without industry and businesses in the local area to help us, this program could not have gotten off the ground. That concept of joining business, industry, and education together, the only way that we can accomplish a master goal is with them.
Today, representatives of the area business and industrial community routinely visit our classrooms, offering instruction and insight only practical experience can offer.
We think it's important that we have in the future a group, a pool of technically educated engineering people to draw from, not only to do what we traditionally had thought of as engineering, or in my case metallurgy, but technical people to be involved in sales. Very importantly, technical people to be involved in manufacturing.
I think it's really interesting when people come in from outside, because when you're working in the classroom, you just kind of get into the routine that everything is textbooks and just these machines, and when they come in from other places, you kind of get a view of where you're going to use this and how it's going to come into play when you get a real job.
To facilitate the partnership, a pre-engineering advisory council represented by college educators, business, and industry was created. Working with the school staff, the advisory council developed a strategic plan, program goals, and strategy for implementing a program of technical preparation.
I find that it's very important as a representative from a university that we be actively involved with the breeding grounds, if you will, where our future students come from.
The Advisory Council has empowered the community to affect the future path of education and the quality of the students they may someday hire.
It's a vehicle for bringing to the local school boards and the local secondary and elementary school administrations the needs of industry, the need for producing a student body that has stronger math and science backgrounds, a student body that's equipped to enter into the more competitive world of technology.
The Shenendehowa program is counted as a plus in attracting new industry to the region.
When I talk to a prospective industry that comes into the area and is looking to make a location, I talk to them about the programs that we have in place that are going to guarantee a quality labor force. This program is orienting and developing potential quality, technology, literate workforce for those prospective industries.
The walls of a classroom can create a border that establishes the limits of a student's education. The partnership we have forged has removed barriers and opened doors to field expeditions where students are exposed to the real-world experiences of professionals.
One of the things that you start to develop in school is how to lay out a building. But what you don't realize in school is the fact that owners, regardless of what you know is right and you know is wrong, they want what they want. And sometimes there's absolutely nothing you can do to change their mind except give them what they're looking for.
To ensure the continued pool of technically skilled students, it is essential to look beyond today's high school seniors. Our pre-engineering students routinely take their knowledge to grade school classrooms, where wide eyes wonder at the technology.
Right now I'm just sprinkling iron filings on here to show you what the magnetic field looks like. And it goes all the way around the magnet and covers it all like that.
Before an entire class or in small groups, the hands-on approach is utilized to teach as well as create interest in the pre-engineering program.
Okay, now try it on the end.
It is here we sow the seeds of engineering excitement in the fertile minds of a new generation.
Now, this is a magnet, all right? Now I turn this on. So what's it gonna do?
The light bulb's gonna light up.
Why?
Because the electricity's going through the magnet. It's gonna charge it.
I hope the students will be more interested in science and in math, science, and technology when they get into the high school, and will pursue careers related to math and science and technology, because they are getting an opportunity to see hands-on some of the exciting things that you can do in this field.
In one period, this experiment has generated an interest that can last a lifetime.
All right, flip the switch. Let it go. Watch your hand.
Let it go?
Yep. I hope I excited them, and I hope I, changed their mind a little and made them think a little.
Each summer, Shenendehowa's unique technology enrichment program turns a lazy day into a world of exploration and achievement for 4th through 8th graders. Offered through Hudson Valley Community College, the 2-week engineering summer camps utilize the same equipment as the pre-engineering classrooms, but it's designed to be fun while stimulating an interest in engineering.
For my son, this is better than playing Nintendo. This is better than going to the park. This is something that he really wants to do. He comes out of here every day, and I say, honey, how was your day? And I hear, great. And I wait all year to hear something like that from him.
Not all these children will build manufacturing plants or office towers, but this generation will grow with new goals, new appreciation, and new knowledge. Enrollment in the Shenendehowa program has increased each year as students recognize its value.
Courses are also offered in college, and they're basic requirements in some programs, technical programs. And if you want to go in that program, you're already a jump ahead of the other kids who haven't had these courses. You know exactly what you're doing.
Hudson Valley Community College, one of the sponsors of the Shenendehowa program, has monitored its progress and now offers our graduates up to 9 hours of articulated college credit.
We felt with the credentials that the faculty have, with the facilities that they have available to them, and the capable students that they're going to be working with, we believe that that's appropriate to grant college credit for those courses.
Feedback from program graduates supports the pre-engineering concept.
I think it's a very good program. It gives you an idea of every little type of engineering. It gives you a little bit of everything, so it exposes you, and that's really what you need to become interested in it. Otherwise, I don't know how else you would become interested in it sometimes.
And the faculty of the technical department has found itself recharged.
I was teaching subjects that were part of a dying industry prior to taking the sabbatical. And as a result of improving my skills, I'm much more enthusiastic than I was before.
Higher education, business, and industry has now a vested interest in continuing and expanding our program. This partnership is now empowered to make real changes in education.
We had something more powerful here than we ever dreamed of having. And I think if other schools could learn how powerful this process really is and what it could do for their school, I don't think they would hesitate. I think they'd do it right away.
Educators from as far away as Japan have discovered the Shenendehowa program as they strive to maintain a competitive edge in the world marketplace and prepare students for the jobs of tomorrow.
The success of this program could have a positive effect on our continued national prosperity. We've got to find a way of raising the level of expectation for public education. We can't do it alone. We need to involve people from business, industry, and higher education with us. If we don't successfully find a way to do that, we're not going to make it.